Thank you for the World News for inviting us here today as microbiologists. We're so thrilled to say to you guys about our research. What do we have today actually?
First of all, do you guys know how bad water pollution got ever since the COVID-19 lockdown was lifted?
It got so bad until I don't even know how to fix it. But us microbiologists would know how. And we did found something though. What is it?
What was it again?
Bioremediation.
Exactly.
What is bioremediation, girl?
That's what we are here for today. We are about to show you guys what we have researched on bioremediation in hopes to overcome this water pollution. So, are you ready to show them?
Kind of want to make them curious though.
Well, we can keep them waiting. Water pollution won't.
Oh, they definitely won't, girl.
Okay, so we're gonna get in contact with our microbiologist team and let's see. Bioremediation. Let's go.
Let's go.
Hello everyone, thank you for the World News for passing the live stream over to our team. We are the team of microbiology researchers that have something exciting to share to the world to overcome the current pollution issues, which is bioremediation. Let's get rolling our bioremediation.
Hello, I'm Mangkyong. We are a group of microbiologists who are currently researching on bioremediation. Please take a moment to see what we have discovered and hope this helps everyone who are on live watching us. So, what is bioremediation? Bioremediation is a natural and sustainable approach to environmental cleanup that utilizes living organisms to remove, neutralize, or degrade contaminants in soil, water, and air. So it is a versatile and cost-effective technique that has gained significant attention in recent years as a viable solution to address various forms of pollution and contamination. The process of bioremediation harnesses the metabolic capabilities of microorganisms such as bacteria, fungi, and algae to break down hazardous substances into less harmful or non-toxic forms. These organisms can naturally occur in the environment or be introduced to the contaminated site deliberately. They possess the unique ability to utilize pollutants as sources of energy and nutrients, transforming them into harmless byproducts through metabolic reactions. So, bioremediation can be applied to diverse types of contaminants, including petroleum, hydrocarbons, and heavy metals, or also pesticides and other industrial pollutants. It is particularly effective in treating soil and water contaminated by oil spills, leakages from underground storage tanks, agriculture runoff, and industrial waste. Thank you, and I will pass the slide to Danya.
Thank you, Moon-kyung. Now I'm going to talk about environmental pollution. So as we all know, environmental pollution has always been an issue since decades, and now it is on the rise ever since the COVID-19 lockdown was lifted and everybody got back to their daily routines. There are so many factors that contribute to environmental pollution, which is why it is so hard to control. A few of the factors are deforestation, water disposal, carbon monoxide pollution, mining activities, and fossil fuel burning. These factors can lead to pollution like air pollution, water pollution, and land pollution. As environmental pollution is on the rise, research strategies for bioremediation in emerging pollutants are now being discussed. Bioremediation got its name as the pollution solution. Now, in the next slide, I'm going to show a viral TikTok video in 2022, which gained over 60 million views, which shows the contaminated coastal lines in Guatemala. So we can see how badly affected the coastal lines in Guatemala are due to contaminants such as plastics and toxins. Bioremediation hopes to overcome and find a solution for issues like this. So now, how would bioremediation help us? Let's move on further into the slides to see all about bioremediation. That's all from me. I will now pass the presentation on to Weng Hang to talk about data statistics and the types of bioremediation.
Thank you, Diane, and I'm Wing Hing. And now I'm going to share about the data and statistics of the major technique used in bioremediation. As you can see, this data, it shows the global bioremediation technology and service market forecast from 2022 and 2030. So due to rapidly expanding population, urbanization, and industrialization, the Asia and Pacific region is expected to be the fastest growing region with a market share of 22.15% in 2021. So during the projected period, the government regulation and initiatives to enhance the waste management and prevent the trash environmental and health dangers are expected to drive the market expansion. And according to the Inwood research, the global bioremediation technology and service market will grow at 8.47% in compound annual growth rate. And in the past 2 decades, the innovative techniques and also concepts for handling the soil that is contaminated has arisen. And due to the financial advantages, the in situ bioremediation are currently adopted more frequently than ex situ. And this trend is expected to continue during the estimation period in 2021 and 2030. And for the types of technology that is widely used in the market is phytoremediation, biostimulation, and bioreactor. And next, I'm going to present about the types of bioremediation based on the microorganism. So the first one is phytoremediation, is that they will use the plant to bind and remove the contaminants, and they are involved in sewage treatment, removal of toxic metals from contaminated water bodies, and removal of pesticides in agricultural soil. Next is bacterial remediation. It's a process of neutralizing and removing the contaminants using microorganisms such as bacteria, which involve at least two types, which is aerobic and anaerobic. So for the aerobic bacteria such as Pseudomonas and Acinetobacter, they are able to degrade the complex compound like pesticides, hydrocarbon, alkanes, and many of these bacteria, they will use the contaminants as carbon and energy sources. And for the anaerobic bacteria, it's used for the bioremediation of chlorinated aromatic compound, degrading and converting contaminants to a less toxic form. And last one is microremediation. They will use the fungi to neutralize and remove the contaminants, and the fungi digestive enzyme are capable enough to convert the contaminants such as pesticides and hydrocarbon into harmless compound. And that's all from me. Thank you. And now I will pass it to Riri.
Thank you, Wayham, for the slides. Now we shall talk about uses of bioremediation. So first example that I have is soil recovery from biomass. The elements contained in wood ash are important for leaf chlorophyll synthesis, root development, and reproduction. High concentration of wood ash promote plant growth and yield the year after burning, although most of these nutrients are highly lost by leaching within few months after being deposited on the soil surface, and then gradually decrease during the failure period. This gradual decrease in soil nutrients during the fallow period is due to absorption by the trees in fast-growing secondary forest. After the secondary forest grows, it will gradually restore soil nutrients. Moving on to the wastewater treatment. Wastewater from the recycling operation frequently contains combination of pollutants that need to be treated. Lucky we have cyanobacteria, which is typically highly effective at eliminating nitrates since they do need nitrogen for their metabolism. Moving to the next one, we have bioaugmentation. As you can see, the example of the picture are on the slides in the middle. The basic approach of this method is to enhance the rate of or extent of degradation of contaminants by introducing contaminant degrading microorganism. This not only remove contaminants in the specific location, but it also increases the genetic potential of site of interest at the same time. Comparing bioremediation using bacteria and inorganic fertilizers in fixed bed aerobic reactors, the bioaugmentation and control categories had 66 and 50% microorganism respectively, and a degradation rate of 75% was achieved in contrast to the degradation rate. So for the last of the example, we have treatment of contaminated petroleum hydrocarbon environment. The biodegradability of organism and their properties are powerful technologies that can effectively assist in remediation of sites contaminated with petroleum and hazardous waste. In some cases, it may be sufficient to simply add decomposition accelerator to the contaminated system. And one of the technique is physico-chemical methods, which includes remediation, reclamation, and contaminant techniques that use physical and mechanical barriers to recover and separate contaminants in soil, sediments, surface water, and groundwater. That's it from me, and I shall pass it to Katima right now. Thank you. Thank you, Ririna. Now let's talk about process of bioremediation. There are two processes of bioremediation, ex situ and in situ. Factors to consider when choosing this process includes the type of pollution, the nature of pollution, the type of environment, location, and cost. The, uh, the performance of the process also being affected by factors such as pH, temperature, and oxygen available. Now let's talk about what is ex situ process. Is digging up the contaminated from and moving it from the area of contamination, moving away from the area of contamination. There are two examples, which is solid phase treatment. This process involves digging up the contaminated soil site with organic waste such as leaf, animal, and agricultural waste and piling up together. And then the growth of the bacteria growth is transported by pipes that were installed in the piles. Moving air through the pipes is required for ventilation of the microorganism respiration. Example of this include biopilots, land farming. And then let's move to slurring phase bioremediation. This is the easiest and fastest method than other techniques. It includes adding adding the contaminated soil with water, nutrients, and oxygen for providing a habitat for the microbes. The added water is determined by the concentration of the contamination and the rate of biodegradation. Sorry for that. And then the soil is collected. After that, the soil is collected and dried using a pressure filter or a vacuum filter. And then the last step is disposing the soil for an advanced treatment of the soil. Now let's move on to in situ process. This is treating the contaminated soil in the site of contamination. There are two examples also. This includes biosphine, which is injecting pressured air into the underwater table to increase the level of oxygen and the breaking down of pollutants by microbes. This process enhanced the mixing of the saturated zone, resulting to a great contact between the soil and the underground water. It is a convenient process and also low cost, and it's also flexible. And then now let's move to the other process, which is bioventilation. But it's a new potential method, which only requires the supply of oxygen to the microbes that were already there. And it's not a big process. Here are some images to give you an idea of the process. This ex situ process example is land farming technique, which is also similar to the solid phase treatment, which is digging the contaminated soil and piling up together. And then in ex situ, in situ process, we have biospatching process, which is injecting pressured air into the ground to raise the level of oxygen and also the rate of breaking down the pollutants by microbes. Now I'm going to invite Nivita. Thank you.
Thank you, Katima, and now I'll be talking about pros and cons of bioremediation. So we'll focus on pros first. Firstly, cost effective. Bioremediation is inexpensive. Toxic waste removal is cheaper with bioremediation, and this also takes less people to work for it. Secondly, eco-friendly. Bioremediation restores the environment and this improves health, environment, air, water, and soil. Bioremediation repairs environmental damage without damaging fragile ecosystems, unlike excavation. Avoid harmful substances. Instead, fertilizers stimulate bacteria, reducing ecological stress. And thirdly, we have scalable. Bioremediation works for small dumps to a large water treatment plants. US sewage treatment plants process 34 billion gallons of wastewater every single day. This is how bioremediation adapts. And lastly, on site, bioremediation is usually minimally disruptive. This lowers the hassle and risk of transporting lots of trash. Toxic waste removal is cheaper with bioremediation. And I'll be looking into cons. So, firstly, digging and pumping for ex situ bioremediation takes time. Second, toxins may not be entirely converted into harmless products depending on the location. Third, some contaminants cannot be biodegraded while others are mobile and dangerous if transformation stops at an intermediate molecule. Fourth, not all compounds are disposed to a quick and complete degradation process. Therefore, it's restricted for biodegradable compounds. And lastly, bioremediation is effective waste management. However, it cannot be eliminate all pollutants. Bacteria can digest chlorinated pesticides and oil spills, but they can't digest heavy metals like lead or cadmium. So that's all from me. Thank you very much for listening. And now I'd like to pass on to Moon Kyung.
Thank you so much, Nivita. In conclusion, bioremediation stands as a powerful and environmentally conscious approach to combat the challenges of environmental pollution. By harnessing the inherent abilities of living organisms, bioremediation offers a sustainable and cost effective method to restore contaminated sites and safeguard the health of ecosystem and human populations. The diverse range of bioremediation techniques, including microbiome remediation, phytoremediation, mycormediation, and rhizomediation, it provides a flexible toolkit to address various types of pollutants in different environmental settings. So these techniques leverage the natural processes of enzymatic degradation, metabolic transformation, and immobilization to effectively break down or neutralize the contaminants. So, what are the advantage? The advantages of the bioremediation are evident. It aligns with the principles of sustainability, working with nature rather than against it. It minimizes the disturbance of the environment, reduces the of additional waste, and avoids the reliance on costly and intrusive methods like excavation and transport of contaminated materials. Moreover, bioremediation has the potential for the complete degradation of pollutants, leading to long-term and sustainable remediation outcomes. Bioremediation has proven successful in a wide array of applications, ranging from the cleanup of oil spills, contaminated soil to the treatment of the industrial waste, and the restoration of fragile ecosystems. Its versatility and adaptability make it a valuable tool for addressing pollution in diverse environments, including terrestrial, aquatic, and even atmospheric settings. So, ongoing research and technological advancements continue to enhance our understanding and application of bioremediation. Scientists are also exploring genetic engineering techniques to optimize the capabilities of microorganisms and plants, as well as developing innovative strategies to combine bioremediation with other remediation methods for complex contamination scenarios. As we move forward, it is essential to recognize the limitations and challenges associated with bioremediation. Factors such as the nature and concentration of the contaminants, environmental conditions, and the availability of suitable organisms or plants can influence its effectiveness and time frame. Rigorous site assessments, careful planning, and monitoring are crucial to ensure successful implementation. So, lastly, bioremediation holds an immense promise as a sustainable and effective solution to environmental contamination. Its ability to restore polluted sites, reduce risk to human health, and preserve the delicate balance of an ecosystem makes it a vital tool for a cleaner and healthier planet. With continued research and advancements, bioremediation will undoubtedly play an important role in pollution and fostering a more sustainable future for generations to come. All right, that is all from us. Thank you.
These are our references. So that's all from us. Hope our research has brought some light to everyone's watching, hoping for a better future and a better planet. Thank you again for the World News for giving us this opportunity to share about bioremediation.